All right, so we've been asked to find all the zeros of a given rational function, okay? And there's a few ways to do this, but the most common way, if you're not given any other information other than just the polynomial, is to use what's called the rational zeros theorem. Rational zeros theorem, okay? And you can also, some folks call it the rational root theorem. Roots and zeros mean the same thing, okay? And so given this particular scenario, we're going to take this guy here, okay? And we're going to write all of his factors. So what are the factors of 10? There's 10 and 1 and 2 and 5, okay? And then this guy, we're going to write all his factors. Well, his only factor is 1, okay? So it's 1x to the 4th, okay? And this set of numbers has a special name, okay? This special name, it's P, okay? And this set of numbers, unlike if this was the number 2, it would be 2, 1. You know, if it was the number 4, it'd be 4, 1, 2, because the factors of 4 are 4 and 1, 2, and 2. But since it's just a 1, there's, you know, a coefficient of 1, it's just 1. And this is called Q. And the rational zeros theorem says that if there is a rational, i.e. whole number or a fraction that is a terminating decimal, right? So 1/2, 1/4, something like that. If there is a rational zero or root that is a solution to this equation, it will show up in the list that is created by plus or minus P over Q, okay? So you're going to take every one of these and put it over every one of these. And in this case, it's a 1, so it's pretty simple. It just becomes this list, okay? So plus or minus 10, plus or minus 1, plus or minus 2, and plus or minus 5. Now, let's go back and say this was a 2, okay? If this was a 2, this would be 2, 1. So I'd put all of these over 1, and then I would come down the next line and put all of them over 2, okay? So I'd have, right, 10 over 2, 1 over 2, 2 over 2, and 5 over 2. Now, 10 over 2 is 5, so I wouldn't use that. I've already got it. 1/2 is a new one, so I'd keep it. 2 over 2 is 1. I've already got it, so I would throw that out. And then 5 over 2 is new. So if this was 1, 2, that would give me more possible rational roots. Okay, so scratch that out. That's not our problem, but that's just a hint. All right, cool. So what we're told is you've got 2, 4, 6, 8. Okay, so you have 8 possible answers, and we need to figure out which ones work. And the way we're going to do that is with synthetic division. Okay, so make sure you've seen, well, I'll go through it anyway, so it doesn't matter. So synthetic division, you're going to go through and write these coefficients: 1, 3, -11, -3, 10. Okay, so 1, 3, -11, -3, and 10. Okay. And you're going to try dividing by each of these numbers. Now, I have a pattern. You do what you want to do, but my pattern is I always start with the lowest whole number, 1, and work my way up. Why? Because division by 1 is a hell of a lot easier than division by 5 or 10 or 7 or any other number, okay? So I'll start with 1, then I'll go to 2 until I find what works, okay? Now, if you haven't done synthetic division before, or you're having trouble with it, it's a real simple process. The first number is always going to get copied. And no matter what it is, you're just going to copy it down. Now, and then it's a series of multiply and add, multiply and add, multiply and add. So we're going to multiply. 1 times 1 is 1. Now add. 3 plus 1 makes 4, right? Multiply. 1 times 4 makes 4. Okay? Add those. All right, well, -11 plus 4 is going to be -7, right? Cool. 1 times -7 is -7. Add these, you get -10, and 1 times -10 is -10, and 10 plus -10 is 0. Now, I got another video on this, the remainder theorem, okay? The remainder theorem says if this remainder is equal to 0, then K, this guy here, he's named K. If your teacher goes on and on about K, it doesn't really matter. You can call it whatever you want to, but most textbooks call that K, which is the attempted root. Then K is a 0. Okay, that's what the remainder theorem says. So, all right, cool. So what does that mean? Okay, well, they asked me to find all zeros. So over to the side somewhere, I'm just literally going to come in here and go x equals 1. Okay? And I'm going to just go ahead and box my answer. And that's my first answer, x equals 1. Now, a mistake most students make is they take these same numbers here and they want to try another 0. Do not do that. Okay, now let me explain. This set of numbers represents a paper didn't want to slide today, y'all. 4th degree polynomial. Okay, you have taken a 0 out. And so now what you are left with is not a 4th degree polynomial. This is a 3rd degree polynomial. This is, follow along with the numbers, 1x cubed plus 4x squared minus 7x minus 10. Okay, so if you to convert back from synthetic division to a problem, that's how you would do it. We don't want to do that, but I just want you guys to make sure you understand those numbers represent that polynomial. Okay, so I'm going to take the 3rd degree polynomial. I'm going to say 1, 3, I'm going to take the 3rd degree polynomial, 1, 4, minus 7, minus 10. Okay, I tried positive 1. Now I'm going to try negative 1. Okay, just try negative 1, see if it works. Okay, and always, right, copy that first number. Now multiply. 1 times negative 1 is negative 1. Okay, 4 plus negative 1 is 3. Multiply. Negative 1 times 3 is negative 3. Negative 7, negative 3 gives me negative 10. Negative 1 times negative 10 gives me positive 10. And you add those up and you get, voila, 0. So what does that mean? X equals negative 1 is also a solution. Okay? Now, the reason that I used these numbers for this second synthetic division is, let's see if you follow along. So we started with a 3rd degree, right? This was a 3rd degree polynomial. A little more lead out here. Okay? That makes this a 2nd degree polynomial. Okay? Well, what does that give me? Well, it's going to give me 1x squared plus 3x minus 10. Now, why is that important? Because now I can stop doing all this. And by the way, just as an aside, if this did not work, I would take this same set of numbers and try positive 2 and negative 2 and on and on and on. Okay, so it just so happens the first 2 worked. Yay, I'm not a genius, I'm just lucky. But this is important, guys, because now we have a quadratic, okay? And we spend a lot of time in math learning how to solve these things. And so you can factor this, you can use the quadratic formula, you can complete the square. And I'm a big fan of factoring just because it's so much faster than the quadratic formula. And so I look at negative 10, and I say, okay, what are the factors of negative 10? Well, you could have negative 10 and 1, or you could have 10 and negative 1, right? You could also have negative 5 and 2, or you could have 5 and negative 2. Now, whenever this guy here is equal to 1, factoring is as simple as, can I find numbers here that add up to that? Well, one of these guys, right? And it's going to be this bottom one. 5 and negative 2 add up to give me 3. So this factors to x plus 5, x minus 2. Okay? So it's going to be that guy right there because 5 minus 2 is 3. Okay? And that works every time as long as this number is 1. And so it's way, way quicker. And then, of course, if you've done this before, you know that x plus 5 equals 0. And so you move that 5 over, you get x equals negative 5. And then here you get x minus 2 equals 0, right? And you move that 2 over and you get x equals 2. And you put those in your box up here with your answers. So, right, we get x equals negative 5. And we get x equals 2. And there's our 4 answers. Okay? So, just, wanted to help you guys out if you run across a problem like this. This is the correct, mathematically correct way to do it. Okay? The only other thing I want to mention is that the fundamental theorem of algebra says that this guy with degree n, so in his case, this is 4th degree because that's the biggest exponent, A fourth degree polynomial is going to have at most 4 answers, okay? And so I get, right, you come down here and see my answers. Well, why my paper's sticking to the table today? 1, 2, 3, 4 answers, okay? So a fourth degree polynomial, once you find 4 answers, you don't have to keep looking. If this were a fifth degree polynomial, then I would ask, okay, we're missing one. Where's the fifth one, right? So anyway, that is using the rational zeros theorem, the remainder theorem, and synthetic division to find all possible zeros for a higher order polynomial, okay? Aside from doing this in pre-calculus, a lot of times you have to do this in calculus because they'll give you a polynomial and you have to find the x-intercepts. And the zeros are, if it is a real zero, that is also an x-intercept. So if you graph this, you will have an x-intercept at 1, -1, -5, and 2, right? So this graph, right, you'd have -1 and -5 and 1 and 2, and this thing would go somehow, some way, it would go through, right, here, 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 and here. It would go through these 4, and so you have to know the x-intercepts to use calculus to further define this function. And so you have to be able to do this, if you're in a calculus class, to be able to do the calculus. So it's just something that, a lot of folks have trouble with. So anyway, I hope that helps. And if you have questions, just leave them in the comments and I'll be glad to answer them.